Millions of bamboo stalks can become soft bamboo-based textiles inside a modern factory. This is the journey from hard bamboo stalks to wearable fabric and finished clothing. The contrast is surprising. A tough plant becomes soft shirts, hoodies, and trousers.
Inside bamboo is cellulose, the starting point for bamboo-derived textile production.
Every stage adds processing, control, and value to the raw bamboo material. The final result is not just fabric, but everyday clothing ready for customers. Now let's follow the full process from bamboo forest to finished apparel. This full process explains how bamboo-based textiles are made, step by step.
The process begins in bamboo forests, where mature stalks are selected for harvesting.
Bamboo grows quickly, making it an important renewable raw material for many industries. Factories prefer stalks with enough size, strength, and cellulose content. Harvesting must be controlled so the stalks can be transported efficiently. After cutting, the long stalks are bundled for transport to the processing plant. Trimming removes leaves and side branches before the stalks enter factory logistics. Large bundles are loaded carefully to reduce breakage during transport. From the forest, the bamboo begins its journey into industrial textile production. Sorting begins early because uniform raw material improves factory efficiency.
The useful textile journey starts inside the bamboo, not on the surface.
Once the bamboo arrives, the factory must convert it into a usable material. The natural harvest is complete, and the industrial process is about to begin. At the receiving yard, bamboo batches are unloaded, inspected, and organized. Damaged stalks are removed before they can affect downstream processing. The factory weighs each batch to plan yield, processing speed, and storage. Batch tracking helps the plant manage thousands of stalks through many stages. Temporary storage keeps the production line supplied without long delays. Surface cleaning removes dirt before the bamboo enters cutting and chipping. Straight alignment helps the machines cut the stalks safely and evenly. Receiving controls the flow of raw bamboo into the entire textile factory. Approved stalks now move from raw material handling into mechanical preparation. This is where the hard bamboo starts becoming a textile raw material. The first mechanical step cuts long bamboo stalks into smaller sections. Uniform sections make the next chipping stage faster and more consistent. Chipping breaks the hard stalks into smaller pieces for cellulose processing. The factory now has bamboo chips instead of long, solid stalks. Screening removes oversized pieces, so processing remains stable. Oversized chips are recut, while suitable chips move to extraction. Washing removes dust and loose particles from the chipped bamboo. Clean chips are staged before entering the cellulose extraction system. Controlled feeding helps the plant keep a steady production flow. Cutting and chipping prepare bamboo for deeper material transformation. The next stage separates useful cellulose from the bamboo structure. Inside closed systems, bamboo chips are processed into cellulose-rich pulp. The hard plant structure gradually softens and breaks apart into pulp. Useful pulp continues forward, while unwanted residue is removed from the line. Filtration helps create a cleaner and more uniform cellulose base.
Technicians test pulp quality before it becomes bamboo-derived fiber.
Material no longer looks like bamboo, but its origin remains inside the pulp. Water removal changes the pulp from thin slurry into a denser material. Some systems form cellulose pulp into sheets for easier handling. This stage creates the cellulose foundation for bamboo-based textile production. Cleaning and refining make the cellulose pulp more consistent for fiber production. Washing removes remaining impurities before the material enter fine refining. Refining improves the texture and prepares the cellulose for spinning steps. Uniform pulp helps create smoother fiber and more consistent yarn later. Fine screening catches small defects before they reach the spinning line. Laboratory testing confirms whether the pulp is ready for fiber formation. Once approved, the pulp moves toward the stage where fibers are formed. The goal is to create a stable base that can be spun into fine filaments.
This part of the factory depends on careful control and clean, closed equipment.
The refined cellulose is now ready to become bamboo-derived textile fiber. Fiber spinning turns prepared cellulose into long, fine textile filaments. Tiny openings shape the material into continuous strands of fiber. Drawing stretches the fiber so it becomes stronger and more even. The newly formed fibers are washed before drying and collection. Drying stabilizes the fibers so they can be cut, crimped, or spun. Thousands of fine filaments are gathered together into soft fiber bundles. Crimping gives fibers texture, making them easier to process into yarn. Some fibers are cut into staple lengths for traditional yarn spinning. The fiber now feels soft, but it must still become strong yarn. This stage transforms cellulose into the fiber used for bamboo-based textiles. To make yarn, loose fibers must be opened, aligned, and drawn together. Carding separates tangles and helps the fibers point in a similar direction. The thin web is gathered into soft strands called slivers. Drawing frames improve evenness by blending and stretching multiple slivers together. Oving adds light twist before the fibers become final yarn. Spinning adds strength by twisting the fibers into continuous yarn.
The yarn must be smooth, strong, and consistent for fabric production.
Finished yarn cones are prepared for knitting and weaving lines.
Yarn testing confirms strength, evenness, and resistance to breakage. The bamboo-derived fiber has now become yarn for fabric making.
The yarn now becomes fabric through knitting and weaving machines.
Knitting creates stretchy fabric, often used for t-shirts and comfortable clothing. The fabric comes out as a continuous tube before finishing and cutting.
Weaving creates a different fabric structure for trousers and stronger garments.
The loom interlaces yarns at high speed to build a stable fabric surface.
Both knitted and woven fabrics are rolled before finishing begins.
Different fabric structures are chosen for shirts, hoodies, and trousers.
Early inspection catches defects before dyeing and finishing add more value. The fabric is formed, but it still needs color, softness, and finishing. This stage turns yarn into the fabric base for finished clothing. Dyeing gives the bamboo-based fabric its final color and visual identity. The color must penetrate evenly so the fabric looks consistent. Temperature, time, and circulation affect the final shade of the fabric. After dyeing, rinsing removes loose color from the fabric surface. Squeeze rollers remove excess water before drying begins. Drying and heat setting stabilize the fabric's width, feel, and shape. Softening improves comfort, especially for t-shirts and hoodies. Some fabrics are brushed to create a warmer, softer interior. Compacting helps control shrinkage before the fabric becomes clothing. Now the fabric has color, softness, stability, and a finished surface. Finished fabric is inspected before it can enter garment production.
Inspectors look for holes, streaks, uneven dye, and surface defects.
Stretch testing shows whether the fabric can perform in comfortable clothing.
Shrinkage control helps the final garments keep their size after washing.
Color consistency matters when thousands of garments are made from multiple rolls.
Strength testing checks whether the fabric can survive sewing and daily wear. Approved rolls move forward, while problem areas are removed or downgraded. Inspection protects quality before the fabric becomes finished clothing. The approved fabric now moves into garment cutting and sewing. Fabric layers must be spread evenly before the cutter begins.
Pattern planning reduces waste and prepares parts for different garments.
Automated cutting creates consistent panels at high speed. Each bundle of panels moves to the correct sewing line. T-shirt assembly begins with simple seams and fast sewing operations.
Hoodies require more parts, thicker fabric, and stronger seam control.
Trousers need accurate shaping, strong seams, and consistent sizing.
Clean stitching gives each garment strength and a professional finish.
Thread trimming and seam checking happen before final finishing. Steam pressing smooths the garments and improves their final appearance.
The textile material has now become finished clothing pieces.
The first final product is a soft bamboo-based t-shirt.
T-shirts need softness, breathability, and stable seams.
Hoodies use thicker fabric for warmth, comfort, and structure.
Trousers require strong construction because they face more movement and wear.
One bamboo-based fabric supply chain can support many different garment types.
The garments are displayed without branding to focus on the manufacturing process.
Measurement checks confirm that garments match the required size range.
Finished garments are tested for seam strength, surface quality, and wear resistance.
Approved clothing is folded, sorted, and prepared for packaging. Final garments carry the story of bamboo, cellulose, fiber, yarn, and fabric. After inspection, the garments move into packaging and distribution.
T-shirts are folded quickly and packed for retail or online orders.
Hoodies are bulkier, so they need careful folding and box packing.
Trousers are packed by size, style, and shipment destination.
Final package inspection checks sealing, shape, and product count.
Robotic palletizers prepare large orders for warehouse storage and shipping. Wrapped pallets protect finished garments during storage and transport. From the factory, the garments move into the global clothing supply chain.
A journey that began with bamboo stalks now reaches stores and customers.
On the shelf, the clothing looks simple, but the process behind it is complex.
The final product connects bamboo harvesting, cellulose processing, textiles, and garment manufacturing.
Every step turns a hard plant into softer and more useful textile products.
The difference between raw bamboo and finished fabric is the power of processing. Finished clothing depends on every earlier stage working correctly. This is the full journey from bamboo stalks to wearable garments. A textile factory brings together many specialized machines in one continuous system.
From forest to fabric, bamboo-based textiles show how modern manufacturing transforms materials.
Every stage adds value, from raw bamboo to clothing ready for daily use.
The next time you see soft fabric, its story may begin with a hard plant.
Thank you for watching Mega Processing Tech. Please subscribe, like, share, and comment what factory we should explore next.